Hey folks, this lesson is triangle proportionality theorem. Okay, this is module 17.1 in our integrated math 2 class. So here's our question. When a line is parallel to a side of a triangle, so it's parallel to this side, and it intersects the other two sides in different points right there, how does it divide these two sides up? And so we're going to discover that with our proportionality theorem. Okay, so in our module 18, we're going to need and that's coming up within a week, you guys. We're going to need graphing calculators or scientific calculators, not graphing. Okay, you're going to see this on the next few lessons anyways, this purple stuff right here. Okay, so it's given here that this line is parallel to this line right here, okay? And so we want to prove that this piece over this piece equals this piece over this piece. So see this proportion right here? We're going to prove that right there. And what we're going to do is get similar triangles right here. Okay, so there's the given information right there. So we know that angle 1 and 2 are congruent and 3 and 4 are congruent because they're called corresponding angles. So that gives us these two triangles right here, okay? So here we got this triangle, and so I can say that this triangle is similar to that triangle because they are similar by angle, angle, similarity. Angle, 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 angle. So because they're similar, then the corresponding sides are proportional. So looks like I did righty over lefty equals righty over lefty right there, okay? So AB is going to be first and second over the first and second equals the first and third over the first and third. So this one is because corresponding sides of similar triangles are proportional right there. All right, so now we're going to do what's called the segment addition postulate. So let's go over here. So we're going to use the segment addition postulate and say AE plus EB equals AB. Do you remember that? And AF plus FC equals AC right there. Okay, that's what we're going to do right there. Okay, now we're going to use the substitution property, and we're going to substitute in. Here's AB, so we're going to substitute in this right there. Here's AC, so we're going to substitute in this right there for that AC right there. Okay, all right, so now we're going to go ahead and get the common denominator. Since they both have a common denominator, we can separate up this over this plus this over this equals this over this plus this over this, okay? All right, now this is just 1 and this is just 1, so we can go ahead and replace those with just 1s. We're just simplifying right there, okay? Let me squeeze that up, make it a little bit smaller. Now remember, our goal is AE over EB. Okay, here we have EB over AE. Okay, here we have FC over AF, and we want it to have AF over FC. Okay, so let's take away these 1s on both sides. We're going to subtract both sides by 1 right there. Okay, subtraction property. And then these are just the reciprocals of these, so we can just call that the reciprocal property. All right. So what does that mean, you guys? That just means this, you guys. If a line is parallel to one side of a triangle and it intersects the other two sides, then okay, so here's this segment is parallel to this segment right here. Then what that means is it divides up those sides proportionately. So top over bottom equals top over bottom, okay? So that's what that means right there. Or we can do this. Now your book doesn't say this, but we can do bottom over top equals bottom over top. This over this equals this over this. Okay, notice I'm doing lefty on the left side and righty on the right side. We can also do this, you guys, top over whole. So this piece over the whole piece equals this piece over the whole piece. And we can also do bottom over whole equals bottom over whole. We can do the whole on the top too, you guys, if you wanted to. So find the measure of each, okay? So here we go. So they want us to find CY right there. So we'll just call that X right there. And then we'll just do lefty over righty, okay? Lefty over righty equals lefty over righty, and when you do that we can cross multiply, so we get 9x equals 10 times 4, which is 40, okay, and then divide by 9 we get 49s, okay? I like improper fractions, okay? Alright, so here we're looking for Pn, so here's Pn, we'll call this x, so we can do top over bottom, okay? Just make sure you're consistent on both sides right there. Cross multiply and we get 15 halves right there, okay? All right, so the converse of the triangle proportionality theorem just says this: if a line divides two sides of a triangle up proportionately, so here if top over bottom equals top over bottom, then that means this is parallel to this, okay? It's just a reverse of that, okay? Okay, so that's what that says right there. It means it's parallel. So verify that the line segments are parallel. Okay, so we got to verify that lefty over righty equals lefty over righty. Okay, so here we go. So we're going to put those lengths in there, and then we reduce those guys. They both reduce to 1/2. So since they both are equal to each other, then that means that those lines are parallel. Okay, how about this one? So here we'll go, is lefty over righty equal to lefty over righty? Okay, so here we go. Let's plug those lengths in right there. Okay, I know 9 goes into those guys, 10 and 8 times, but also we can reduce 10 and 8 by 2's, okay? And then on this side, I multiplied this by 1, but my 1 was 10 over 10. That just moved the decimal over one place and added a 0 right there. Okay, so let's go ahead and reduce 5 and 4 right there. And then here I divided, because I knew those are both divisible by 5, so when I divide them by 5, we get 135 over 108. Okay, do you guys know the divisibility trick with 3 or 9? Well, if these add up to a divisibility of, tongue twister, of 9, 1 plus 3 plus 5 is 9. These add up to 9. 9 goes into both of those, so if you divide those by 9, we get 15 and 12, okay? And then 3 goes into both of those 5 and 4 times. So look, this side is 5/4, this side is 5/4. Since they're both 5/4, that means that those lines are parallel. All right, if you are in our class, that's going to be your assignment. Take care.